Morning. I am Arnaud Boris. I am manager of Lubmarine for the American zone, and I'm glad to be with you all today and with our team. Part of our team is in South America, in Caribbean, and in North America, and the rest of the team of Lubmarine is in France mainly. And all together, we have prepared this webinar on shipping to be able to present you new technologies and products and services. So I would like to welcome everyone to this webinar. We are sorry for the technical issues that we have faced with Teams. Sometimes the technology in IT is not simple, but hopefully now we are all connected and we are glad to have you on board to start this webinar. I will just present rapidly the agenda of our webinar. So we will present briefly Lubmarine at a glance. It will be done by Paulina and Carlos. Then we will go for the technical purpose of our meeting with Nicolas that I will introduce later. And then we will keep 15 minutes to have a question and answer Q&A session to be able to reply to all your questions. So first, for those who don't know very well our company, I would like to emphasize some concept. As you may know, Lubmarine is part of the company TotalEnergies. We have changed our name recently, a few months back, and this change comes from an ambition that our company has communicated widely, and this commitment is to participate to the challenge of the climate change. That's why our company is developing and is growing with high ambition in the development of new energies to reduce the carbon footprint in all activities as well as for our customers. So now, what are our values as Lubmarine, TotalEnergies Lubmarine? We are committed to better shipping, which is related to the commitment of our company vis-à-vis our customer and vis-à-vis our market. The shipping industry to cut its GHG emission by at least 50% by 2050 compared to 2008. So this is the first commitment we have to participate with you as a client and with all our customers. TotalEnergies joined the Get to Zero coalition, also part of this ambition and this commitment for the climate challenge. And as Lubmarine, we are participating in the development of marine LNG supply with a lot of infrastructure that we are developing worldwide to propose to the marine industry a cleaner energy with less CO2 emission. 90% of everything, it is 90% of the good we consume comes to us by a ship. 60,000 deep sea vessels is our target business. 7,000 vessels lubricated by Lubmarine. All vessel types with tanker, containers, and bulker representing 75% of the market. I'm sorry, I'm trying to go fast because we have lost a bit of time, and I would like really we take the benefit of Nico's presentation. Paulina, I pass on to you the next talk, and then we will go with Nicolas.
Thanks, Arnaud. Please move to the next slide. Thank you. So, hello everyone, my name is Paulina Muñoz. I am a South America Marine Manager, and I'm delighted to be with you today. As Arnaud said, we will do this very briefly because the idea is that you can hear Nico's presentation. But I want to share with you some facts about Lubmarine. We are part of TotalEnergies Lubrifiant. Lubmarine is a global business unit of TotalEnergies company. Next, Arnaud, please. Okay, so we have Lubmarine has 69 years of experience in the market. We have been delivering services and lubricants since 1952. And we are proud to mention that during all these years, we have achieved important results. Like, for example, a long-lasting legacy with more than 4,000 days without any accident. Important product developments like Talusia Universal and environmentally accepted lubricants or biolubricants. Successful support to our customers on the switch over to IMO 2020, among others. So after all this history of successes, where do we stand right now? Next, Arnaud, please. Lubmarine is currently positioned as the #2 globally in the lubricant supplier market, with a market size in the deep sea lubricant market of about 2 million tons. Right now, Lubmarine has more than 200 colleagues working exclusively for Lubmarine activities. We cover 1,000 ports in more than 100 countries, and we work with 60 blending plants around the world. Some of them are directly owned by Total and other through our partners. Next, Arnaud, please. Okay, so thanks to our portfolio of products and services, as well as our logistics solutions, we can offer to different markets and different customers, like the offshore vessels, special vessels, deep sea vessels, cruise and ferries, naval and short sea shipping vessels, like the ones most of you can see in our region, bulkers, tugboats, tankers, barges. And also, we have a very interesting offer for the power plant industry. Next, Arnaud, please. Very important to mention that through our research center in France, we can anticipate fast changes in the market in order to adapt our product and services to our customer needs. That's the case of the single oil concept, like Talusia Universal, the fuel economy engine oils, environmentally acceptable lubricants, LNG fuel engines, and future fuels like ammonia and hydrogen. Next, Arnaud, please. Through our research center, we are also committed to formulate new products as well as improve the existing ones. Everything of this is done with our OEM approvals, with whom we have a very close relationship. And the last one, Arnaud, please. Okay, so last but not least, it's very important to mention that we cover a wide range of services as well, as we foster a complete customer experience for each one of you. We can offer onboard equipment, laboratory services, drain oil analysis and optimization, and of course, the support from our technical experts. So that's everything from my side. I welcome you all to our webinar, and I give you the floor back, Arnaud. Thank you.
Okay, thank you, Paulina. Last things I would like to comment before giving the mic to our friend Nikos. During the Q&A session, as we have people from various countries, and especially South America, if someone wants to ask some question, if he feels more confident to ask question in Spanish or Portuguese, we are here to translate. There is no issue for us to do that with Paulina and with Carlos. So, Nicolas started his career in shipbuilding, holding various positions in ship repair and new buildings projects in Greece, Germany, and USA. He joined TotalEnergies 10 years ago, and since July 2020, he holds the position of Technical Director of Lubmarine. Nicolas holds a master's degrees in naval architecture and marine engineering, in business administration, and in international business from Greek, British, and French universities. He is registered as a chartered engineer with the Engineering Council in UK and as European engineer with the FERANI. So we are happy to have Nikos here, and I pass on to you the mic, Nikos, for your technical presentation.
Thank you very much, Arnaud. So Etienne, let me know when my slide is on.
It's on.
Yes.
Thank you. So welcome everybody. Once again, apologies for this delay. I'll try to cut some corners in my presentation. Everything will be there, everything will be recorded, everything will be shared with you later on. Feel free to ask any questions. I have many things to see today, I think interesting things. And I hope you will also enjoy this presentation. So the agenda for my today's presentation is to go through the shipping trends, then to have an overview of our engine lubricants portfolio, and I'll give you a few words also on our new product development program, and in particular the development of new cylinder oils and the new 4-stroke fuel economy lubricant, before I close with a quick word on our technical services. So shipping is certainly under scrutiny, is certainly under stress. Everybody's looking forward to this decarbonization. Wanting it or not, it will be there and it will accompany all our actions in the coming years and maybe the coming decades. And the most important is to see, when we talk about decarbonization of the shipping industry, we have to see what are the big categories in this. So the first one is the energy efficiency. Clearly, when we want to reduce our CO2 emissions, we have to reduce our energy demand. This is straightforward, this is clear, and this is the first of the 4 pillars of the decarbonization, the way we see it. The second big pillar is the propulsion efficiency. So, assuming that we have done everything we can in order to reduce the demand, the next pillar in this process of decarbonization is to improve our energy usage, is to become more efficient. And in the case of the ship, this goes back to propulsion. The third is self-explanatory, the use of low carbon energy. So apart from the efficiency efforts that we did in the first 2 pillars, in the third one, we change the fuel itself, the energy source itself, into sources that are less carbon intensive. So this is a carbon, our intervention, the carbon intensity of the energy source that we'll be using. And the fourth pillar is the carbon capture, which means how we can capture all what is emitted as a CO2 from our ship after having followed this path of these 3 pillars before reaching the capture, the fourth one. So when it comes to energy efficiency, we can split this into 2 big branches. The one is the vessel design, and vessel design is something that it is a one-off process. It is linked to the genesis, to the very creation, to the very construction of the ship, with the form optimization, with the optimization of the ship size dimensions, the weight, the use of materials, the use or not of a bulbous bow, new hull coatings, air lubrication, and so on and so forth. All this, let's say, gets under the category of vessel design in energy efficiency. Then we have another part which has to do with the operation of the ship. So the first one is design, the second one is operation. And in the operation, we find all the measures that we have to employ in order to improve our efficiency, like the speed reduction, advanced port logistics in a way that our port calls will be shorter and our standby time outside ports will be also as short as possible, will be minimized to the maximum. the weather routing, the cleaning of the hull, the propeller cleaning and polishing, and so on and so forth. These are known to the market already because this is what we know as EEDI and EEOI, which will become EEXI, so the Energy Efficiency Design Index and the existing ship index as well. Now, moving to the propulsion efficiency, we focus more on the powertrain. So the powertrain is the engine, is the propulsion, and the propeller, the shaft machinery in the propeller. So in the propeller efficiency, there are many options known, like the large area propellers, the pre-swivel and post-swivel fins, the ducts, like the Mewis duct, the contra-rotating propellers, and so on and so forth. In the engine efficiency, we focus more on the engine, so we have the enhanced fuel injection systems, hybrid diesel-electric operations, early intake valve closing, so it has to do with more items related to the mechanical engineering, related to the design of the engines itself, but also related to the operations and the post-treatment, like the waste heat recovery. There's one link here to the fuel economy lubricant, but you will see this more in detail into the next slide and to some slides that will also follow. And there is the more experimental, I would dare to say, path of having a propulsion assistance and the power assistance by using the Flettner rotors or kites, sails, even solar panels and shore connection. Now, moving to the carbon energy, things are pretty straightforward. I think you all know what you will see here is new fuels and new energy sources. So we have LNG, ammonia, methanol, biofuel. You've heard this already in many different occasions, in different fora, in different conferences. We have also new energy sources like batteries or fuel cells. And finally, the carbon capture, which is, again, more of an ambitious future development, which is relating to the onboard CO2 capture. Now, in this presentation and in the next slides, I will focus a bit more on the new fuels and energy sources because I think that this is what seems to be a driver in the technological development, knowing, of course, that all the part related to the energy efficiency, to the propulsion efficiency, is already very much important, but it has already been covered very well, and there are so many solutions that are already out there in the market, and there are known and mature solutions for the operators to use. But before talking about the new fuels, we have to talk about the new engines. So there are efficiency evolutions on two-stroke and four-stroke engines. And these efficiency evolutions, they can be split into categories. We have the incremental evolutions of the internal combustion engine, an engine which is well known. It was designed by Otto back in the 19th century. Then we had the by Rudolf Diesel, and then we had the Otto cycle, then we had the Miller cycle. So from the time of Rudolf Diesel, of course, today there are many things that have been improved, and we still continue to improve all these different small parameters like the turbocharging, the variable port geometry, smart control, electronic control of the engines today. We have an increase of the mean effective pressure, and we are working on the reduction of the friction losses of this engine. At the same time, we have the energy efficiency outside the internal combustion engine, so a post-treatment efficiency related to the waste heat recovery or even to electric hybridization. Now, I would like to focus on 3 points here. The first one is the mean effective pressure. So we see that in the coming 10, 15 years, you see over the last years how much the pressure has raised, because the pressure is directly linked to the performance and to the efficiency and to the specific fuel oil consumption of the engines. So the higher the pressure, the lower the consumption. So it's a key part of the engine efficiency. Now you see that in the next coming decade, we should expect another increase of about 5% in the pressure. And this is something that we see both let's say the two bigger OEMs in terms of sales, MAN and WinGD, converging to this possibility for the future engines. The second point I would like to note is the electric hybridization. because this is linked to a potential electrification of the powertrain. And this can be very promising for an efficiency increase. And you see here how this is this could be the arrangement in an engine. So you have a main engine connected to a shaft generator, which at the same time, if it is given energy, it can be turned to an electric motor. And then from the shaft generator, we have the battery pack frequency converters, and we have the auxiliary engine. So all of the systems, we can either move power from the main engine to the system and to the batteries, or from the battery pack back to the shaft propeller and to the propulsion of the ship. And the third point that I would like to underline here is the friction losses, and this is directly linked to the development of fuel economy lubricants. So fuel economy lubricants that show a considerable performance, at least the one that we have designed, it is very, very promising. There are further tests to follow, and in the coming slides, in this part here, where you see on the top right side, the fuel eco, I will give you some more information about what we've already seen and what we aspire to see in the future in the field of a fuel economy 4-stroke engine lubricant. And I would dare to say, of course, that they are certainly an option to consider given their interesting cost to benefit ratio. So, moving away from the engines, we have to put the energy source to those engines or to the ship. It could be via an ICE, an internal combustion engine, or directly from a battery electric arrangement, from a hydrogen, or even from fuel cells, as you see here. You see on the left-hand side, the size of a container ship of about 185,000 metric tons. And in this container ship today, we have the fuel oil tanks, which take about 10,500 metric tons. So it's roughly about, you see the ratio here between the fuel oil tanks and the container ship. It takes some space. It takes about 5% or 7% of the ship weight. And this is what we consider to be the norm for long haul, for deep sea vessels. If we were to replace those fuel oil tanks with batteries today, it would take about 460,000 metric tons for the same range. I repeat, for the same range, for the same nautical miles, for the same autonomy. In 2030, this is expected to be reduced by 50%, but still it would be about 230,000 metric tons compared to 185,000 metric tons where we have the ship, including the cargo and the fuel. In the case of hydrogen, so battery electric, purely battery operated ships are not in the coming future cannot be considered a viable solution. If we move to hydrogen, there is a very big difficulty in keeping it in liquid form, and this is the liquefaction temperature, which is at minus 252 degrees Celsius. Today, we're having issues in keeping the LNG in liquid form at minus 160 and less than 160. So you see that there is, let's say, a very clear and objective difficulty in using hydrogen on those ships, which is the temperature, but also linked to the energy density per volume and the very high flammability of hydrogen. Hydrogen here, I mean H2. So the battery electric technology could be suitable for short sea vessels, certainly, in competition maybe with hydrogen fuel cells. So maybe not for a long haul container ship, but for a short sea, for a short sea ship, it could be an option to use battery, of course. And the third option, which still seems remote, is the direct ammonia solid oxide fuel cell, where we have the case of a very efficient option, which is not mature. It doesn't have any combustion, so it is safer, but it is still not technologically mature, and we might have some difficulty in upscaling it. So the conclusion in this slide is that for deep sea ships, battery electric is not realistic, hydrogen is not promising, but the solid oxide fuel cell with ammonia for internal combustion engines could be considered as a long-term viable option. But this is, let's say, very much in the sphere of a long-term future. Let's go a bit closer to today, where we have the LNG and we have other options that we hear in the news in scientific papers all around. The LNG, the methanol, the biofuel, and the ammonia. So LNG is the best mature option for an immediate reduction of CO2 emissions today. We know this. We know that it has low pollutants. It's a supply chain which is well established and it can be also ammonia ready. So there is a link with the future option, but it is still perceived as a transition fuel with limited greenhouse gas reduction of greenhouse gases. The methanol, there are different options, different derivatives, the pure methanol, the biomethanol, the e-methanol, all of them they have their own set of advantages and disadvantages. We would say that the most difficult part in methanol is that it's not a drop-in fuel. We cannot use it right away. So there is a lower density, of course. It is more expensive, but it could be an option. So keep this, that methanol is seems to be a viable option. Biofuels as well, especially the biodiesel, can be an option, can be a drop-in fuel, which means that we can use it seamlessly with the fuels that we have today. It has a high energy density, but there is a limited feedstock and there can be a huge competition with road transport and aviation. So this means that when something becomes, let's say, the demand of a commodity like biofuel increases, it means that the price will increase as well because we have a limited feedstock, which means that we cannot increase the supply at the same time. So most probably it will be used at more premium prices at different markets. Finally, the ammonia, the NH3, is the real zero carbon fuel. It can be used in combustion with a dual fuel engine or used in the SOFC configuration, as I showed you in the previous slide. There is no apparent competition with other transport modes, so it can be perceived clearly as a fuel of the future. Now, all of them, they have, as you see here, a set of advantages, of some considerations in yellow and some disadvantages in red. This is not an exhaustive list of advantages and disadvantages, but what it shows, what I aimed at showing here, is that all of the above solutions are expected to be employed by the shipping operators in the future. What cannot be clear and cannot be said for now with certainty is the adoption rate of each of these solutions, because it will depend on a series of technical, economical, and logistical factors. What I would dare, if I had to make a, let's say, a forecast, I would say that most probably we'll move from LNG to a bifold solution between methanol and ammonia. And biofuels, given, again, the competition with other markets, it could be a bit less interesting for the shipping market, at least cost-wise. Now we'll move on to a quick overview of our engine oils portfolio. And I would like to start by seeing the Telusia range, our Telusia range and the product commercialization timeline. So you see our Telusia is our flagship range. It is our cylinder oils used on two-stroke engines. And the development of our grades is certainly linked to the sulfur content of the fuels. And in the sulfur content of the fuels, we have to see the global sulfur cap and the sulfur emission control areas. So for the last 20 years, 25 years now, we had a Telusia HR70, our BN70 grade, which were along the years covering different ranges of sulfur content. This is also linked, of course, to the engine design. So we have the BN, we have the Telusia part, we have the sulfur content in the fuel, and we have also the engine design, that they all interacted together in order to give us the ranges on what you see here for all of these different grades. Along those years, we had also LS40. So you see that these are two grades, the BN70 and the BN40, which have run through almost a bit more than two decades, maybe even more than that. And they have been covering the market at different circumstances for different limits. Around the year 2007, we had the introduction of Telesio Universal, which today seems as the perfect fit between the ships that are operating on VLSFO or even dual fuel engines, and even in some cases as a low BN for scrubber equipped engines. We will see more about Telesio Universal in the future because we see that it is a solution which certainly answers to many of the customer and the operator needs. There was a short-lived product which was the LS25, brought into the market in 2014 and withdrew from the market last year. And this came to cover a very particular situation where we had the 0.1% sulfur fuels in SICA, in sulfur emission control areas in Northern Europe and Baltic Seas, and in California waters. And then it was further developed to the whole US waters and Canada. We had the Telesio Universal 100, we still have it, of course, which is a BN100 grade for ships which required a higher neutralization capacity. A very special Telesio Optima, which was intended for a wide range and is intended for a wide range of fuels, and it is a very premium grade used in case where all the rest of our lubricants, they cannot find a solution. Telesio Optima seems to have this solution for the operators. And we have the HR140, which is for the high for the heavy residual and high sulfur content fuels used by engines that are principally equipped with scrubbers. So you see that for about 20 years we had, or for about maybe 7 years, we had only one grade, and for about 15 years we had introduced a third one. So there were 3 grades which were developed in a year range of about a period of about 15 years. And in the last 6-7 years, we had another 4 products that saw the light of the day, bringing the total number of cylinder solutions at 7, and today at 6 because the LS25 is decommercialized. So you see that this shows for me the rapidity that things change in the market, and that newer solutions are always necessary in order to make sure that we answer to the technological evolutions of designs and the new fuels that are coming into the market. I would say that 2004 for shipping was the era of the upscaling. So we saw the ships that they started to upscale. We had the VLCCs and the ultra large tankers and bulkers. We had also the container ships moving from 3,000 to 4,000 TEUs to 20,000 TEUs. So amazing things have happened over the last 15 years. The 2010 was marked by what I would call the slow steaming, because it was the market crash that brought slow steaming in the market. The slow steaming then, it gave its place to the cold corrosion era around about in the 2015. And I think that we are now entering a new cycle, and this new cycle is the cleanliness era. So we need clean engines for many reasons. So the Telesio range, as I said before, there are 6 products in our portfolio to cover all your needs. You don't have to remember this by heart, but you have to know that our marine lubrication engineers and our local sales teams and our local technical correspondents are in position to help you in choosing always the right solution, irrespective of the engine that you have, if it is an MAN engine, a WinGD engine, or a Japan Engine Corporation engine. We are there to provide the right solution based on the engine design and the fuel that you're using. I would like to focus a bit more on the 2-stroke engine makers, and in particular MAN and WinGD. So MAN, with the service letter issued last year, the service letter number 694, we have the introduction of a 2-tier product market with a category 1 and category 2 cylinder oils. And we are working on developing cylinder oils, low BN cylinder oils in category 2. And this is the part that I will be showing you in the next slides. But keep in mind also that Telesio Universal is not listed here, as it is a category 1 cylinder oil. You should not consider these lists complete because there are other category 1 cylinder oils with no objection letters from MEN Energy Solutions that are equally suitable, and I'll show you also the no objection letter later on. WinGD is following a different approach, but at the end of the day, it is very much aligned. They're both very much aligned, so they're still allowing 15 to 25 BN oils for operations in dual fuel engines, so either LNG or up to 0.1% sulfur, 40 to 60 for anything up to 1.5%, and so on and so forth. So 140 is what they, BN 140, so the HR 100 is the HR 140 is what they propose from anything above 3% sulfur. So why do I insist on TotalEnergies Universal? I insist because it is the single cylinder oil solution for all 2020 compliant fuels. And we have a no objection letter from MEN since May 2020 that validates that TotalEnergies Universal can be used on any engines operating on less than 0.5% sulfur and anything from 0.5 to 1.5%. And we have the same no objection letter with MEN from WinGD, like the one we have from MEN, we have it from WinGD, which is even more, let's say, valuable for us because with TotalEnergies Universal, we managed to run also a DF validation. So it is a DF validated. It's one of the few cylinder oils which has been validated for dual fuel engines by WinGD. I will now speak a bit about our four-stroke engine lubricant selection, and I would like to focus on three key parameters. So the first parameter is that when you select a four-stroke engine lubricant, you have to know what the OEM is, because the OEM will influence the kinematic viscosity, if it is an SA30 or an SA40. The second is you need to know the fuel, because based on the fuel, we'll have to choose the BN to match the more severe condition. So if it is intermediate fuel oil or heavy fuel oil with scrubbers, we'll have to go to solutions like BN30, 40, or 55. If it is a VLSFO, anything between 20 and 30 should be okay. Distillates from 12 to 15, and pure gas, anything from 4 to 7 BN. And the third is, of course, the trade, because the fuel that you use today doesn't necessarily mean that you will use it tomorrow. So we have to have this information related to where you will be running your assets, your ships, so that we can give you also the best possible advice in choosing the right product for your engine and for your operation. Our series is a complete series, so anything you need is there. Aurelia LNG starting from bottom to top, Aurelia LNG for the pure LNG operations, Diesel M with BN12 or 15 for distillates operations, Aurelia TI in BN20 and 30 for VLSFOs, and the Aurelia TI in BN30, 40 or 55 for IFO, HFO together with scrubbers. Now, I told you before that I would talk about our new product development. So our new product development projects are very much, let's say, at the forefront of the technological age on the technological advancements, and this is necessary because anything that we develop will have to be used today and tomorrow. So we have to take into consideration the newer engine designs and the newer operations when it comes to designing a cylinder oil. So we have three OEMs, MEN, WinGD, and Japan Engine Corporation. And we see that all their engine designs are, let's say, covering different operational and environmental factors. The operational factors are straightforward: better reliability, extending the maintenance intervals, higher engine ratings and combustion pressures for fuel efficiency, and of course the environmental factors related to the emissions control, the use of alternative fuels, so that the operators can have a lower carbon footprint. So we see on the right-hand side a cylinder. As the piston goes up, everything takes place within a very short space, which is the top land and the ring lands. So this is the key cleanliness parameter for a new cylinder oil. We need to keep this part clean, because as soon as we keep this one clean, the engine would be running smoothly. This is what our experience shows over many years of product development. The same applies now also on the exhaust valve. We have to make sure that the exhaust valve stays clean and the whole post-treatment system is not polluted by the cylinder oil that we will be using. So the key specifications for us for any new cylinder oil is the deposit control. Make sure that it contains low ash, it has a low ash content, and the cleanliness. We need it to have high detergency. Thus, our project development has been codenamed LAHD. Now, we have to understand the importance of keeping these ring grooves clean, because we hear it all the time. It has to be clean. Everything takes place in the first top plant and the ring groove, but we don't really understand why. So you see here two photos. The one is the clean engineering movement, and the second one is with detergency problems. To understand what's going on, when everything is clean, the pressure of the combustion chamber passes at the back of the ring, and it pushes the ring against the cylinder liner. As soon as this is accomplished, we have a very even and balanced stresses on the ring, what you see here in red color. This is schematic, of course. You don't have to take it one by one, but you have to understand the concept that the pressure needs to be evenly distributed as the OEM has designed it to. And you see here in yellow the cylinder lube oil film. If there are deposits, we are starting to have rings that stick, and as soon as they stick, we will have a loss of pressure at the back of the ring, and this loss of pressure will allow for blow-by gases to pass at the front of the ring and start pushing the ring also and creating a back pressure on the bottom of the ring. And there is a ring collapse danger in this situation. This is why we have to avoid these deposits in order to make sure that the rings will be doing their job. If the rings are not doing their job, then half, let's say, of the game is already lost. As soon as we have a proper combustion chamber and the clean engineering movement, we have a proper sealing of the combustion chamber, clean ring grooves, free ring movement, and balanced stresses on the ring. If we have deposits, we have limited and sticky ring movement, combustion gases blow by, imbalanced stresses, and the risk of ring collapse. So the project approach for us has been to keep the ash content low for a BN level at about 40, boost the cleanest performance, make sure that we work with components that are mature and available worldwide, and of course, always respect the HSEQ compliance of all components that we will be using. We have been working on this for over a year now. Approval field tests are already planned and are due to start soon, and the results are expected in the second and third quarter of 2022. And I hope that I will be able to meet you in person by that time and be the bearer of good news on our product development, on our new cylinder oil development. I would like also to give you a few words about our fuel economy development on our the four-stroke engines, the Aurelia series. So the classic Aurelia TI that I showed you before has a native package containing detergents, dispersants, and anti-wear with a base oil mix, and it is mainly an SA40 monograde lubricant approved by the OEM. In the development of a fuel economy, we had to add a new detergent mix, a new friction modifier, and also viscosity modifiers. So there is a brand new additive package and brand new design philosophy. It's a design philosophy that is the first time that anyone has ever dared to try on a marine engine environment. This gives a multi-grade lubricant, which is currently not approved by the OEMs. We hope, of course, and we are in these talks with all of them to start tests in the coming months on this. But we did run one fuel economy test to make sure that we have a proof of concept. We have the validation that what we have been developing makes sense and it produces results. So I will not enter much into the details. Of course, I'll be open to discuss with you individually if if this is of interest. But I think that the big picture is that we run it on on a ship equipped on a RoPax, so on a ro-ro passenger vessel, equipped with 4 engines. And every set of engines, we tested it one against the other, so the Aurelia fuel economy against the standard Aurelia TI, and we did the same on 2 sets of engines. And we added mass flow meters, Coriolis flow meters on all of these engines, one by one, to make sure that we can accurately measure the fuel consumption. And depending on the engine output, we measured an average of 4.7% of fuel economy. It's huge. It's huge. It's something that we, even ourselves, would not expect. We, of course, want to verify this through more tests. And if you're interested to participate in the field test trials for this new fuel economy lubricant, please do contact us, because we want to gather as much information as possible. We will not market it with this fuel economy, but this is a very good indication, and this gives us the courage to continue to move on and try more tests to see what it gives us. Once again, 4.7% of average fuel economy based on the ship and the load, this particular ship and the load profile of its engines, of their engines. And as I always like to close my presentations, I would close this with a question: how to ensure that the appropriate lubricant, that the lubricant is in appropriate condition and performance in the long run? And the only solution for this is through monitoring services. So Paulina already mentioned it in her introduction. There is a complexity. Lubricants and products is only one part of the equation. Services is the second, because we can use a great solution, but if we do not follow through, the solution will not work the way we expected it to. So we need to rely also both on the product and on the monitoring on the services. So from in our side, Lubmarine, we're offering a full lab analysis scheme with a complete set of onboard kits for a comprehensive analysis of trends with the assurance of our technical expertise. For any complexity, we are here to help you and would be glad to do so. So thank you for your attention. That's all from my side. And I would be happy to answer to any questions that you may have.
Well, thank you very much, Nikos. Just before seeing the Q&A part of our webinar, I would like to thank the marketing team of Lubmarine, who has prepared this webinar with our team. As you saw during our presentation, and in particular the presentation of Nikos, TotalEnergies is a leading energy company offering and promoting new energy as well as innovative solutions to support our clients. This is our company ambition. We would like to support the customer and market expectation to tackle the climate change challenges. As Lubmarine division, we are acting the same way to lead the change with our customer facing this challenge, because all the marine industry as well as all industries are facing this climate change. And Lubmarine is aiming at proposing technical, innovative solutions with product as well as services. In a next webinar, probably for Q1 or Q2 next year, we will see. We will also present you some technical, innovative solution as a service that our company and our team is working on. And next year will be interesting for us to present these new innovative services to support this change and to optimize your operation. Now we will move to the Q&A session. Paulina, I don't know if you have the first question that we received from our customer and colleagues.
Yes, so thank you, Nikos. I just received some questions for email, so I am putting them on our window here. The first one is, can bio LNG become more relevant as a fuel in the marine market compared to regular LNG?
Yes, can you hear me? I don't know who's on direct.
Yes, I can hear you.
So the more relevant as fuel, anything that the source, it's the same as the methanol, the same as the ammonia. The bio LNG is not necessarily going to change as long as it is LNG. It's not going to change the carbon intensity. So the different solutions are related to the production means. So seeing it as a supply chain, it can have an effect, it can have an influence, but it will not necessarily be more relevant in a way that the one solution will follow the other. They can run in parallel, and this is something that we can expect, having also bio solutions. But as long as there is carbon in the solution, this means that this solution is considered a transitory one. The same applies for methanol as well. This is why what we see as future solutions is ammonia and hydrogen.
Thank you, Nikos. I have here a second one. Those LNG powered ships need a liquefaction plant to cool down LNG in long sea passages?
No, because first of all, we have to remember that the LNG has been used in LNG carriers in a way that you do not have to re-liquefy it. It's not liquefaction, it is a re-liquefaction. You're just using the boil off gases. And this is what we're using with the LNG carriers already. So the LNG carriers, they're carrying the LNG in liquid form, and they're taking the boil off gas and they're using it in engines, in the two-stroke dual fuel engines. So this is the way that we have this technology, and this is the way that we can work also on different ships and different configurations. The only thing is that the tanks will have to be different, of course. So if you're not an LNG carrier, you do not have LNG tanks. So in order to have LNG powered ships, which are not LNG carriers, it means that it has to be a provision already from the shipyard. It is very difficult to retrofit. We can do it, but it is in fact difficult to retrofit a ship to make it LNG powered.
Okay, I have a third one, but I will do a quick announcement first. Estas preguntas fueron enviadas en inglés por un cliente en Chile, pero si alguno de los asistentes quiere enviarnos su pregunta en español, por favor envíenlas y nosotros hacemos la traducción, no hay ningún problema. So, Nikos, the third question is that I have here is the marine bunkering sector working today to be prepared for LNG bunkering in the main ports of the world in the near future?
The answer is yes and no. It is clear that the LNG supply chain is not as extended as the marine fuel supply chain. So the problem, into quotation marks, problem that we might face is with the Trump shipping. So if you have ships that they call in exotic ports, the LNG supply chain cannot be, of course, everywhere assured. But we've seen that, in fact, there is only a very small percentage of the ships that they do not call at some point, at one point or another, one of the most frequent ports. So Singapore is an example, for example, 60% or more of shipping passes through Singapore. Now, in the past, it could be that it has not been our preferred bunkering option for various reasons. So there are those ships which will be the early adopters, which are clearly the containers, the liners. So when you have a container ship that serves a line, you are an early adopter because you know the ports that you would be calling. And then as soon as the infrastructure will become more mature, we will have the bunkers and the tankers following suit, with the option of course, in the beginning, opting for the most frequent ports. So there will be a supply chain, not huge, but certainly enough to cover at least 80% of the shipping needs in the beginning.
Okay, thank you. I received this by WhatsApp, and it is if there is any ongoing ammonia ongoing project with any vessel powered with ammonia.
There is no vessel powered with ammonia today, so there is no project. There are experimental engines with ammonia, and we expect the first engines to come in the next 2 years. And there's also another question here, if we think, I see Etienne, there is a question from the moderator, if we think that ammonia is a premature technology to discuss today. So if you will allow me, Paulina, I will just use this question to give a bit more, a broader spectrum answer. When we talk about a solution which will come in 2030 or 2035, it sounds really, let's say, far from today. Okay, it's a solution that we do not expect tomorrow. The question is that this solution will affect our fleet today, because if we order a new ship today, it is an asset, and we have to make sure that we will have a return on our investment of this new ship in its lifetime, in her lifetime. And the lifetime of a ship today is about 20 to 25 years. So if you buy something today, this something is not prepared for what will come in 2030, it means that the lifetime of this asset will be reduced to maybe half of what you would expect. So the question is, are we buying a ship or ordering a ship today, which will be delivered in 23 or 24, with the provision to work with the technologies that they will come to the market in 2030 or 2035? Or should we buy a ship today that we know that her lifetime will be less than 15 years? This is the big, let's say, question that the operators have to answer. Either we buy something with a reduced life cycle, a reduced lifetime, because it will not be adapted to the future technologies, or we buy something today with the provision to be LNG ready, as it was some years ago, ammonia ready today. So at some point, it's a chicken and egg dilemma. If there are no ships ready for this technology, there will be no infrastructure. And if there is no infrastructure, there will be no ships. So what I show here is that there is a tendency which is coming from external factors, from environmental factors, that we have to go for the decarbonization, and this is a fact. And the only way to go to decarbonization is to pass through these teething problems, these small problems in the beginning, in matching the right supply, in the right demand, in finding the right answers to difficult problems. And there are no right answers to difficult problems. There are only good guesses. And the only thing that we can guess today is that, as it happened with the scrubbers, there are people who opted for scrubbers and operators who opted for scrubbers and operators who opted for VLSFO right away, the compliant solution. The same thing will happen in the next generation of ships. Some of the operators, they will stick to LNG, some they will move to methanol, some they will even try to have an ammonia ready ship, or even put rotors and the sails on their ships. Everybody will try something different, and the early adopters is the ones that they will drive the market. So the question is how the operators, they want to position themselves. Do they want to position themselves as an early adopter or as a follower in the changes? Whatever they choose, we will be there with the right products for them.
Yes, what you just said, I think is the key idea for all of our participants today. Whatever they do, we will have the services and the product to support them.
We just need to make sure that they are more, let's say, sensible to what it means, those new solutions, because when we first discuss about this, it is a natural tendency to say that this is too far, 2030, who cares, I will be in pension. I mean, not me personally, but or in 2035, who cares? We do care, because we do not have, we have to see this as on the basis of the asset. So if we want our asset to be viable 10 years from today, we have to make sure that it will be, let's say, possible and will be still valid for the solutions that we will have 10 years from today. It's like buying a car today. If you buy a car today which will not be able to work on new fuels or on, I don't know, a hybrid engine or an electric vehicle, batteries or whatever, today it means that most probably it will have a limited lifetime, at least in the big cities.
Okay, perfect. Thank you. One more question here. Can you please explain what is bio-LNG and if it's also used for powering ships?
My presentation was supposed to be more general. So bio-LNG, it has, as I said before, it has to do with how it is produced. It is a matter of the production of LNG. So LNG can be produced. LNG is anything that has a single carbon or a two carbon chain. So it is the methane and the ethane. So when we have methane and CH4 and C2H6 is what we consider as LNG. What it is, when we go to C3H8 and C4H10, it is what we usually call LPG, the petroleum gas. So the LNG is either a natural product that we have ready as LNG, or it can be also the process of waste, either human waste or animal waste. We can produce LNG also in different forms. There is a part, or it can be also from crops. There is a part which is all these different, when we call biofuels or biodiesel or bio-LNG, it doesn't necessarily mean that it is 100% bio. So we have also a 20% bio, a 30% bio. There are different scales. We can mix bio solutions and non-bio solutions. But what needs to be clear to everybody is that bio or not bio, the exercise is how to decarbonize shipping. And in order to decarbonize shipping, we have to take carbon out of the equation.
Thank you, Nikos. I have one more here. Does TotalEnergies have an expectation to have the Talusia fuel economy approved by OEM? This fuel economy is an excellent value.
Happy to see, first of all, that you see it as an excellent value. I tend to agree to this. Yes, we have the expectation to have it approved by the not one OEM, but at least 3 OEMs. But there is one slight detail here, that the OEMs, the way that they, it is a technical legal issue. No OEM will validate the fuel economy performance. They will validate the lubricity. So they will validate that this as a lubricant protects the engine. The fuel economy needs to be validated by a third party accreditation body, or yes, a validating body. It can be a classification society, most probably, or another sort of validating societies and validating bodies. Why? Because the OEM, as soon as they validate the fuel economy performance for the fuel economy performance, what they do is that they take an engagement and they assume a responsibility for this performance. So the whole idea, the whole point here is that the OEMs, they will be validating, and this is the discussions that we have with them already. And if we manage to be successful to this, and we hope that we'll be successful, we will be covering at least 70 to 80%, not 80, but maybe 70% of the market with those approvals. The OEMs, they will validate the lubricant performance of the fuel economy, Telluce fuel economy, or Aurelia fuel economy, and then an external accrediting body will validate the fuel economy performance. And this is part of our plans. And for the second pillar, for the second option of this validation, so the fuel economy, anyone who wants to be involved in this from our operators is welcome to contact our sales forces and our technical colleagues.
Perfect. Thank you, Nikos. I think that's the last question I have here. So Arnaud, I believe you want to end now. I want to thank you, Nikos, for the presentation. Very interesting indeed. I know we are recording it, so we will share with our customers and some of them that they were not able to join us today. So thank you.
Yes, thank you, Paulina. Thank you, Nikos. I'm sorry, I had to go out for a couple of minutes because in TotalEnergies, safety is the first value, and we had a safety exercise that required everyone to go out of the building the time we verify the alarm. Just to comment on the last very interesting question, I would like to comment and to reemphasize the comment of Nicolas. We count on our customer to prove the fuel economy that we have worked on with this product. So, as Nicolas well explained, to assess the real value that we have calculated and work on with our research center and all the people having worked on the development of this product, we need our customer to use the product and to assess for each vessel and each operational condition the economy and the savings that the customer will measure. So we count on you to prove that, and we know what we have worked on, but it's up to you to verify the economy and the saving that you will really see in your operational condition of your vessel. So we are very open to your proposal and your contact to organize those assessments with all the support of the commercial team as well as the technical team under Nikos' management. So if we have no further question, again, I would like to thank all the attendees, all our customers and colleagues having participated to this webinar. I hope that everyone has appreciated the same way as us, and I wish you a good day. Sorry again for the delay and technical issues with team tool that we have experienced. And tomorrow we have another seminar which is on power gen. I know we have a number of customers subscribed for this webinar, and hope next year we will organize other webinar. Gracias a todos, obrigados a todos, nuestros amigos de Brasil y nuestros amigos de South America. And gracias a Nikos and the marketing team for your support in organizing this event, and gracias Paulina and Carlos for the work also to organize this webinar. Hope to see you soon. Bye bye.
Bye. Merci. Gracias.